Welcome to this class. This session, we are going to introduce the concept of Cayley-Hamilton theorem. So we say that every square matrix satisfies its own characteristic equation. I remember this is how we define characteristic, this characteristic polynomial, taking the A matrix minus lambda I and finding its determinant. So this is characteristic polynomial. And so when you equate it to 0, now you get what we call characteristic equation. So once you get the characteristic equation of any square matrix, then that characteristic equation is satisfied by the matrix A itself. So that's why to say that from this characteristic polynomial, then if you replace lambda for the matrix A, then it will be satisfied in such a way that when you put replace A for lambdas, you will end up with getting, so this 0 in this equation will be a 0 matrix. And this is an identity matrix of order similar to this order of matrix A. So we are going to do a problem to illustrate how this theorem is applied to specific matrices. So say, so problem. Find the characteristic. Find the characteristic equation of the symmetric matrix given by A is 2 minus 1, 1 minus 1, 2 minus 1, 1 minus 1, 2, and verify that it is satisfied by A, and hence obtain A inverse. And then next part of the problem, express A power 6 minus 6 A power 5 plus 9 A power 4 minus 2 A cubed minus 12 A power 2 plus 23 A minus 9I in linear polynomial in the matrix A. So here is a problem. Now, this is simply asking you to prove the Cayley-Hamilton theorem and then use the Cayley-Hamilton theorem to play with this polynomial in terms of the matrix A to the point that you get a linear polynomial in A. That means that you get an expression where the highest power of A is 1. Now, solution. Characteristic equation is given by A minus lambda I equals to 0. that the determinant of A minus lambda I gives you 0. So determinant of this matrix will be 2 minus A minus lambda I is 2 minus lambda, minus 1, 1, minus 1, 2 minus lambda, minus 1, 1, minus 1, 2 minus lambda. This should give us 0. Now let's expand along the first row. So my plus sign, minus sign, plus sign. So we'll have 2 minus lambda times the submatrix, determinant of the submatrix 2 minus lambda, minus 1, minus 1, 2 minus lambda. Minus minus will be plus, so plus 1, minus 1, 1, minus 1, 2 minus lambda, plus 1, then minus 1, 1, 2 minus lambda, minus 1. This should give us 0. That is the process of finding the characteristic equation of the determinant of this matrix here. Now we'll have 2 minus lambda. So this by this will give us 4 minus 4 lambda plus lambda squared. Minus 1 is positive 1, so minus 1 plus 1 into minus 2 plus lambda, minus minus is plus 1, plus 1 into minus 1 is positive 1, minus 2 plus lambda equals to 0. So I'll have 2 minus lambda into lambda squared minus 4 lambda plus 3 minus 2 plus lambda plus 1 plus 1 minus 2 plus lambda equals to 0, which will be 2 lambda squared minus 8 lambda plus 6 minus lambda cubed plus 4 lambda squared minus 3 lambda. Now here I have minus 2. So minus 2 plus 1 plus 1 minus 2, get minus 2. Lambda plus lambda is 2 lambda equals to 0. So I rearrange minus lambda cubed, so plus 2 lambda squared, so minus h, and then minus 3, then plus 2. I get minus 9 lambda. Constants I'll have 6 minus 2, that will give me 4. So this is the characteristic equation, or dividing through by -1, I'll have negative a positive lambda cubed minus 2 lambda squared minus plus 9 lambda minus 4 equals to 0. So this is the characteristic equation of matrix A. Now, by Cayley-Hamilton theorem, we expect to have, so replace lambdas by A, so A cubed minus 2A squared plus 9a minus 4, but then because we're dealing with matrices now, 4i should be given by 0. So let's verify this. So let's say this one star. Verification of star. So a squared is the same as, so we have matrix 2 minus 1, 1 minus 1, 2 minus 1, 1 minus 1, 2. You multiply by itself, 2 minus 1, 1 minus 1, 2 minus 1, 1 minus 1, 2. So multiplication of matrix is row by column. So this will be 4 plus 1, 5 plus 1, 6. So I get here 6. And then 2 minus 2 minus 4 minus 5. And then this will be 2, 3, and then plus 2 is 5. And if you do multiplication, you also find that this is minus 5, this will be 6, this will be minus 5, this will be 5, this will be minus 5, and this is 6. Now, a power 3 is the same as a times a squared. So just have 2 minus 1, 1, minus 1, 2, minus 1, 1 minus 1, 2. You multiply by what you have gotten for a squared, 6 minus 5, 5 minus 5, 6 minus 5, 5 minus 6, 6. So the assumption taken here is that you know how to multiply 3 by 3 matrices. So let me just demonstrate how to get the first one. So the 2 by 6 is 12, minus 1 minus 5 is 5, so that will be 17. 1 times 5 is 5 plus 17, 22. So this will be 22. If you work out this position, will be negative 21. This will be 21. This will be minus 21. This will be 22. This will be minus 22. This will be 21. This will be minus 21. This is 22. Please confirm those values. And so a cubed minus 6a squared plus 9a minus 4i will be given by 22 minus 21, 21, and then minus 21, 22, minus 21, 21, minus 21, 22, minus 6. A squared was 6 minus 5, 5 minus 5, 6 minus 5, 5 minus 5, 6, and then plus 9. The matrix A is 2 minus 1, 1, minus 1, 2, 1, minus 1, 1, minus 1, 2, minus 4 times identity matrix. So identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. So to add matrices, we add corresponding elements. So we'll have 22, then minus 6 times 6 is minus 36. 9 times 2 is 18. And then minus 4 times 1 is minus 4. And if you work out, the next one will be minus 21 plus 30 minus 9 plus 0, minus 0. And then we have 21 minus 30 plus 9 minus 0. This will be minus 21 plus 30 minus 9 minus 0. 22 minus 36 plus 18 minus 4. Minus 21 plus 30 minus 9 minus 0. This element will be 21 minus 30 plus 9 minus 0 minus 21 plus 30 minus 9 minus 0, 22 minus 36 plus 18 minus 4. And when you do this summation, you should get 0, 0, 0, 0, 0, 0, 0, 0, 0, which is indeed a 0 matrix. So it is verified that the characteristic equation is satisfied by A. Now, the inverse. So the next part was to find the inverse of A. Now, we have A power 3 minus 6A squared plus 9A minus 4I is equals to 0 matrix. So applying A inverse on both sides, we have A, so we have A inverse multiplied by A power 3 minus 6 A inverse multiplied by A squared plus 9 A inverse multiplied by A minus 4 A inverse multiplied by the identity matrix to give us a 0 matrix. So loss of indices, this will give us A squared minus 6, this will be A, and then plus 9 A inverse, A is identity matrix, and then minus 4 A inverse equals to the 0 matrix. Now, make this the subject. So we'll have 4 A inverse equals to A squared minus 6A plus 9 times identity matrix. So which means 4 times the inverse will be A squared. We calculated the answer as 6 minus 5, 5 minus 5, 6 minus 5, 5 minus 5, 6 minus 6 times matrix A is 2 minus 1, 1 minus 1, 2 minus 1, 1 minus 1, 2 plus 9 times the identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. So for A inverse, so this addition of matrices just add element wise. So we have 6 minus 12 plus 9 minus 5 plus 6 plus 0, 5 minus 6 plus 0, minus 5 plus 6 plus 0, 6 minus 12 plus 9, minus 5 plus 6 plus 0, 5 minus 6 plus 0, minus 5 plus 6 plus 0, 6 minus 12 plus 9. And when you carry out this summation, so 6 plus 9 is 15 minus 12 is 3. Then we have 1 minus 1, 1, 3, 1, negative 1, 1, 3. So which implies that to get A inverse, you simply divide through by 1/4 or multiply by a quarter into 3, 1 minus 1, 1, 3, 1 minus 1, 1, 3, which you can write it as 3/4, 1/4 minus 1/4, 1/4, 3/4, 1/4 minus 1/4, 1/4, and then 3/4. So that's the inverse. Last bit was to express a power 6 up to that minus a power 9 as a linear polynomial. So we had a power 6 and then minus 6 a power 5 and then plus 9 a power 4 minus 2 a power 3 minus 12 a power 2 plus 23 a minus 9 I. This is what we have to reduce into lower or a polynomial of linear terms in A. So we know that a power 3 minus 6a squared plus 9a minus 4i is zero matrix. So what we do, we are going to force this this polynomial a cubed minus 6a squared plus 9a minus 4i into this equation or this expression, and then simplify and see what is the remainder. So we can write this one as a power 3 into a cubed minus 6a squared plus 9a minus 4i. So first, this term whose value we know is 0 into this equation. So a cubed, a power 3, I'll have this one taken care of. This will also be taken care of because 3 plus 2 will give me 5. And then a cubed times 9a squared. So this term is already taken care of. And then a cubed, remember identity is the same as writing a power 0. So 0 plus 3 is 3. So it's like I've included negative. So a power 3 times 4i or minus 4i is minus 4 a power 3. So it's like I have to add 2i or 2a power 3 so that I have the original expression, because here I have already subtracted another 2i and then minus 12 a power 2 plus 23a minus 9i. So this is 0. So this being 0, so this term is already known. It's like now multiplying by 0. So my solution reduces to 2a power 3 minus 12a squared plus 2a minus 9i. I also force a cubed here, so I can say a cubed, so I factor out 2, and then minus 6a squared plus 9a minus 4i. Let me see what I need to balance so that I have this expression. So 2a cubed, this will be taken care of. And then 2 times 6 is 12. So this will also be taken care of. But 2 times 9 is 18a. But here I have only so this was 23, this was 23 NH2. So just confirm this is 23A. So this is 23A. So this 23A. So when I force this expression, yes, I'll have this is taken care of, this taken care of. And then 2 by 9 is 18A, but this one should be 23. So it means that I need to add 23 minus 18 is 5. So I need to add 5A. And then 2 by minus 4, I have minus 8, but here is minus 9. So then I have to subtract 1. So I have minus 1I, or just minus I. So therefore, since this is already 0, so 0 times 2 is 0, so then that reduces to 5A minus identity matrix. So therefore, that given polynomial in A, which is A power 6 minus 6A power 5, and then plus 9A power 4 minus 2A power 3 minus 12A squared, and then plus 23A minus 9I is nothing but 5A minus I. So you can actually get the value of that when you know the matrix A and then you know what I is. So that's how you get the solution to that given problem. If they ask you now to express into linear terms in terms of A, and then give the structure of the resulting matrix, then you can actually do it from here. Take matrix A multiplied by 5, subtract identity matrix from the result, and then you'll have your solution.